Hi, in this exercise we'll export a GenFEA model to SAP2000 version 25 and compare the analysis results. So here we've got a simple structure with steel elements and also a plain shell element with some quad meshes that was generated by GenFEA. Great, so let's export that to SAP2000. It'll only take a second and then we'll open up this model directly in SAP2000 and look at the results. So over here in SAP2000, we simply go to Import, use the MS Excel spreadsheet format, and we select the file that we've just exported from GenFEA. This will take a minute, so I'll speed up the video so that you don't have to sit and watch the process. Once it's completed, we can see that there are 0 errors, 0 warnings, and no erroneous information. So a very smooth transition, and it's worth noting that all of the steel and framing elements that has been imported, so all the bar elements, have got their sections created using the SAP2000 section designer. So with the import format, we actually specify that all of these sections are custom sections, which means the sectional properties are computed by SAP2000 upon import. So we can see here the properties calculated by SAP2000, and if we compare that with the cross-section properties calculated by GenFEA, we'll notice that they are extremely close, within less than 0.1% deviation. So that's great. So in terms of the cross-section area and the moment of inertia about the X and Y axis, we get exactly the same results, and our value J is the torsional constant, which you can see is very close in comparison with SAP2000. So that is a good start. You'll also notice that the shell elements, the quad mesh elements from GenFEA has been imported, and we've applied a area section in SAP2000 to those elements corresponding to the section properties in GenFEA. Now we're going to jump straight in, run the analysis. So load cases are also brought across into SAP2000 from GenFEA, and the analysis will take just a minute to run. Once that is completed, we are presented with the results, and we'll start off by looking at the deflections, the global deflections, in this case in the Z direction, global Z direction, and we can see we've got a value here on the shells of 3.8 millimeters in the center of those shell elements. And if we run the analysis in GenFEA, it only takes a second or two, and we compare the same results on deflection, you can see that we're getting exactly the same. So 3.883 in that red zone in GenFEA. And again, if we compare that with the values that we get from SAP2000, 3.885, I think, so which is pretty much exactly the same. If we look at the support reactions in SAP2000, we can see that the values also very closely correspond in the various areas or sections or supports to GenFEA in the X, the Y, and the Z direction. So in on the screen now you can see the values in Z, in the global Z, and we can see that they are very closely corresponding to that of SAP2000, which again is great. So yet another area of the model, just to make sure we check all the areas, those with heavy loading due to the shell elements and those just freestanding or without the shell loads. So we can see that those reaction values are very close, so that's good. Okay, so next we're going to be switching on the actual forces on the model. I've also switched on the label so we can see those values. And again, if we do the same thing in SAP2000, switch on the actual forces, we hope to see very similar results. So on the screen there, you can see the values that we're getting from SAP2000, so 62286 on that center column, and if we look there on center column, 62297.3, and the rest of those columns, if we just run through them or navigate through them, we can see that it very closely relates to, again, what we have in GenFEA. Next, we'll look at the shear in the local X direction, and if we do the same thing in GenFEA and we compare results, again, extremely close, those values, within about 1%. And we can see the same thing happening on the shell or the mesh elements here in both platforms. So results very close to each other for framing and area or shell elements. And now we'll switch to the shear in the other direction. So that'll be VZ, and we expect to see the same numbers again between both platforms. So there we've got a value of 1208, I think it was. And if we look at the values that we are getting here in GenFEA, extremely close. Right, so next we'll have a look at the torsion output. So here we can see torsion. We expect to see very low values on those columns, but we do see some torsional values showing up in the shell elements. So we'll just switch on the torsion here in SAP2000, and we can see just off the bat we've got a very similar diagram being plotted, and if we inspect a little bit closer we can start to look at those values. Of course, the scaling differs between the platforms and how it's drawn. You can adjust your scaling in GenFEA. I'm sure you can do the same in SAP2000, but if we look at the actual values, so there we've got 2238.44, and if we compare that with the values we've got in GenFEA, again very close, within a percentile difference, so extremely good. And on those columns we see 0 values, of course, on both of them. So if we now switch to our moments, we can see this is the local X direction moments, and in GenFEA, since we use a different coordinate system, that'll be MYY, but the same thing. So we can see the values again for all of those very close, and we can see the same sort of diagram being plotted, the same mechanism happening in both models, the calculated mechanism in terms of the internal forces and transfer of forces. So that's looking good. If we do the same thing for the moments in the local Z direction, in SAP2000 that'll be moments direction 3, then again we see the same thing. So we're quite happy with those results and confident that they are extremely close. There's a lot of moving parts, of course, how the cross sections are generated, calculated, how the models put together, different analysis engines, but exactly the same geometry. So it's really rewarding seeing that GenFEA is capable of producing very similar results to a high-end, very high-priced structural analysis software that's been around for a long time, such as SAP2000. And of course that means that we're on the right track with GenFEA, and we hope that you like it too. Thanks for watching, and please register to join our GenFEA launch event in Auckland on the 23rd of May 2024.